What exactly is a physics-informed neural network, also famously known as PINN, PINN? Physics-informed neural network is a way in which you can teach your neural network to respect the physics of the system. So let's consider an example where you are throwing a ball up. So you have height as a function of time, and usually this height can be represented almost like a parabola. Let's say you measured the height as a function of time and you got experimental data like this, which is a bit noisy. Maybe this is because you did not perform your experiment really well. Maybe the device you used to measure the height was not good. Whatever it is, if you train a neural network to make predictions based on this data, and if you push the neural network loss to be closer and closer to zero, what happens is neural network will learn to make predictions that are very close to these experimental data points, which will involve loss as well. So you are not just teaching the neural network to learn physics, rather you are brute forcing the neural network to learn on the experimental data pattern, which will involve significant amount of noise. So in this case, the loss, which can be described by mean squared error, is the difference between the predicted value of y, which is the height, minus actual value of y squared, and then you sum it up and divide by n to get the mean of the square of errors. But in physics-informed neural network, you define your loss like this. You can have three loss terms, where the first loss term, which is multiplied by a prefactor lambda 1, is the normal mean squared error, where you consider the difference between the predicted value of height and the actual value of height. Then lambda 2 multiplied by this term is actually where you are incorporating physics, because you know that if you are throwing something v equal to u minus gt is like how the velocity will change with time. And what is v? V is equal to dh by dt, which in our case we can call as dy by dt because we are having y instead of height. Now we can perform something called as automatic differentiation of our neural network, because our neural network is originally predicting height, not dh by dt, but you can calculate the dh by dt or dy by dt by performing automatic differentiation. And then we penalize the neural network whenever the dy by dt prediction deviates from this term u minus gt, because this is how the physics is coming into the picture. Is this enough? No, there is one more thing which the neural network should obey, which is the initial condition. Maybe the ball started going up from an initial height of 2 meters. You don't know that. So you have to also make the neural network follow the initial condition. So here you have one more extra term with the prefactor lambda 3, where you are saying that the predicted initial value minus actual initial value of height, the whole square. So the bigger this number is, the higher the PINN loss. So if you want to just solve the differential equation for the one-dimensional motion of the ball, then you don't need this lambda 1 term at all. You can just set lambda 1 to be 0. So you are not at all considering experimental data. Rather, you are just considering the differential equation and the initial condition. So PINN is a great way to get numerical solution to differential equations that are otherwise difficult to solve.